right, guys, let's get back to this. So this is going to be our last video. Our last video for 2.4 configure and verify layer 2/3 ether channels. Okay. Now, we went ahead and the only one we have not done is the IP address layer 3. Okay, IP address layer 3 is the only one we have not done yet so far. We have a video for static, we have a video for our PAGP, we have our video for our LACP. Once again, remember that ether channels, okay, in my own words, higher, actually a redundancy and higher bandwidth. Higher bandwidth and redundancy via a logical link. You're taking physical links and you're creating one logical link in order to provide higher bandwidth and redundancy. You have a maximum of 8 links. We talked about LACP, that was link aggregation control protocol. It is the open standard. It is the most common. This is a layer 2. We talked about PAGP. This is port aggregation protocol. It's a Cisco proprietary. Okay. We talked about static. Okay. Rather simple. Make sure that if you have the switch on the left as static, make sure that the switch on the right is static. We really did harp on that, apples to apples. Whichever protocol you decide to use, please make sure you use the same protocol across the board. That way there is not any issues. Okay, let's go ahead and, like we mentioned today, what we're going to focus on is IP address. Okay, so ether channels via IP address layer 3. So the first thing we need to acknowledge, okay, the very first thing we need to acknowledge is that we are on a layer 3 switch. We are on a layer 3 switch. For every example that we have used before, we were using a layer 2 switch. So this right here, okay, this right here on top is a layer 2 switch. This right here, okay, is a layer 3 switch. And when we go ahead and reference layer 2, layer 3, what they're trying to reference is the OSI model. And basically, these switches here, these layer 2 switches, let me go ahead, let me get some text here. Layer 2 switches. Okay, and this right here, this is layer 3 switches. Okay, so this right here, guys, when you have your let's go ahead, let's see if we can make it a little prettier. Let's go here, outline, and let's go with blue. Okay, let's go with blue here. So we have this here. Perfect. Now let's go ahead and change the color again. Let's go with red. Okay, there we go. Okay, so that looks a little better. So as you guys can see, okay, layer 2 switches, okay, and layer 3 switches. All the commands that we were doing beforehand, guys, all the commands we were doing beforehand with our LACP, with our PAGP, with our static, those were on layer 2 switches. You could still use those commands and those protocols on your layer 3. However, when it comes to going ahead and creating an ether channel via IP address, you're going to need a layer 3 switch. And the difference is you're creating the ether channel via IP address, okay, which is different from layer 2. With regards to layer 2 is more so communication via MAC address. So it's more so communication physically, like with their physical address, because a MAC address is a physical address. It's something that's burnt into the actual device. It is a burnt in address. It is the physical address of that device, as opposed to layer 3, where it becomes more so of a logical address of the device. Okay, so just keep that in mind. OSI, if you're getting a little confused with regards to OSI, just realize that there's 7 layers. Okay, and then your layer 1 is basically ones and zeros. Your layer 2 is you're dealing more so with MAC addresses and whatnot. Your layer 3, you're dealing more so with what would be IP addresses. Okay, nonetheless, guys, let's go ahead and what we're gonna do is we don't want to delete our layer 3 switch because we're going to need our layer 3 switch. We want to go ahead and let's go ahead and bring back our layer 3 switch. Let's go ahead and do that here. All right, perfect. Okay, so let's go ahead. Let's move this around a little bit. We'll go here, we'll go here. So once again, in order for IP addressing, in order for us to create an ether channel, via IP addressing, we need layer 3 switches. Okay, so let's go ahead. I think I harped on that enough already, but let's just go ahead and we're gonna actually go and create the ether channel. So we're gonna need more than one link, right? Because there we go. Here we go. So this one will have 3. Let's get a little organized on this kind. We're going to have 1.9268.0.1/24, and on this one 1.9268.0.2/24. All right, we can go ahead, we can wait in order for these interfaces to come up. As you guys would expect, when all of these come up, one of them is going to be the root switch and the other is going to go ahead and be the non-root switch. So let's see, these, it looks like they're battling it out right now. It looks like this actually might be the non-root switch. Let's go ahead. We can verify that by going through our enable show spanning tree. Yeah, looks like this is going to go ahead and be the one. Okay, so the bridge ID, remember, it's always with our respective, it's always with the respective switch. Excuse me, the bridge ID is with the respective switch. So the bridge ID is saying, hey, this is the information for this respective switch. And when you look at the root ID, it's the root ID is the root ID for the respective group of switches. So in this case, we only have 2 switches, and it's saying, hey, out of the group of switches, okay, your root ID is this information. It gives you the priority number, address number. It's telling you, hey, this bridge is the root. It's telling you your hello timers. Okay. And when we look at bridge ID, it's looking at the actual respective switch, which in this case, it just happens to be that we looked at switch 1, which is the root ID. If we do the same exact command on show spanning tree, I know here. So let's go to show spanning tree. Okay, looks like it really likes the dash. Show spanning. There we go. Okay, so now on this, as you guys can see, look at what we're looking at. We're looking at switch 2. It's saying, hey, within the group of switches that are connected, the root ID is this. And as you guys can see, the bridge ID is the respective switch 2. And you can see that this here, okay, this here, it has a different MAC address. So you know when you're looking at your command. So now we're back to switch 2. Let's actually just go side to side really quick, okay, guys? That way you guys can see what I want to go ahead and explain to you. So we have our switch 2, perfect, and we have our switch 1. Okay, you guys can see I've already mentioned this, but I think this is critical. That way you guys can go ahead, whether you're taking the CCNA or whether you're troubleshooting, this command here is critical. Okay, it is critical. That way you can go ahead and know exactly how the system is wired, so to speak, and know which switch is which. So switch 2, the bridge ID is the respective information for switch 2. Okay, and as you can see, the MAC address is not a match. Switch 1, the respective bridge ID is going to go ahead and be for switch 1, and you can see that the MAC address is a match. Okay, so there's a matching MAC address, which is letting you know, hey, switch 1, that's going to be your root bridge. The root ID is saying, hey, within these groups, notice how the root ID within this group, it doesn't change. It's only the bridge ID that goes ahead and changes. So that's how you know, when you look at your bridge ID and you see that the MAC address is a match, or maybe that the priority number is a match, or better yet, both of them are a match. That's how you know you have your root switch. So I think we talked about that enough. Let's actually go straight to the command. Okay, so we go into our switch. We're going to go to interface range. First, we got to go to global config mode. Global config mode, interface range, fast Ethernet 0/1 to 3. We're going to click no switch port. Okay, no switch port. Once we get there, we're going to go to channel.group one mode. Now, let me go ahead. Here's the thing. When it comes to layer 3, guys, I want you guys can technically pick any of these. However, apples to apples, oranges to oranges. Keep it the same. If you decide to use the PAGP, you can use the PAGP. If you decide to use the LACP, use the LACP. Me, on this one, I'm going to go with the static. So I'm going to go ahead and click channel group one mode on. Okay, that's good. That's perfect. And now we're going to exit out of here. Now we need to put the IP address. Okay, so if I go to do show run. If I go to do show run, you're going to see here, uh, this link, and this link is going to be where'd it go? Here it is. Interface port channel 1, no switch port, no IP address. Okay, so this link, this interface, and this interface 1, 2, and 3, okay, are on the channel group 1. We need to put the interface on that port channel. We need to put that interface, the IP address on this logical interface, not on the fast Ethernet 0/1 or 0/2 or 0/3. We need to put the IP address on the actual logical interface. So once we go here, we're going to go to config. We're going to go to interface. It's going to be interface. Where is it? Port channel 1. Okay, so interface port channel 1. Okay, IP address 192.168.0.1, 255.255.255.0. Okay, we go here, no shut. Let's exit. We're gonna go to show ether channel summary, and voila. Okay, we have our group, we have our port channel. We already know we use the protocol. It's letting us know which ports are actually being used. If we want to get more information, we can go to show show interface. I believe it was show interface ether channel. That's the one. We actually go to show the interface of the ether channel, and you guys can see we have a lot more information than just the show ether channel summary. Okay, it's letting us know the port state, channel group, mode, okay, so on and so forth. Now we configured it on one side. Let's go ahead and configure it on the other side. So we have this. Now let's go here. Okay, so this is gonna go to, we're gonna go to config T. Yes. Okay, we're gonna go to interface range fast Ethernet 0/1 to 3. Okay, we're gonna go no switch port. Go to no switch port. Once we go to there, we're gonna go to it's gonna be channel. Just in case, let me go ahead. There it is. Channel group 1. Okay. Channel dash group 1 mode. I need to use the same protocol on switch 2 as in this case on switch 3, which was static. Okay. I go there. I'm going to exit out of here, exit out of here. I'm going to go into the interface, config T. And just so you guys can see, show ether channel summary. Okay, so it's giving me this. It's saying, hey, you've created the ether channel. But remember, when I go to show run, if you guys can notice, I do not have an IP address. So once again, I need to put the IP address on this actual interface, on this logical interface that's the port channel. So we go to config T, we go to interface port channel 1. Okay, we're gonna go to IP address 192.168.0.2.255.255.255. Mind you guys, these IP addresses, technically these are considered private IP addresses. Okay, but these IP addresses, they're more so arbitrary. You know, in reality, obviously, in the real world, it's not arbitrary. Everyone has their own IP addresses, got, essentially given to them, okay, by IANA. But nonetheless, when it comes to packet tracer, a lot of these IP addresses are once again arbitrary. Um, the idea is the idea is the idea. The moral of the story is learning how to go ahead and configure this, learning to know how it logically works, learning how these protocols or certain commands, what kind of changes will occur in your network, or what kind of changes don't you want to occur on your network, so on and so forth. So just my little 2 cents here. But nonetheless, IP address, we got that, and we need our infamous no shut command. Okay, so we exit. We're gonna go to show run. Okay, once we go to show run, we can see here we created the interface port channel 1, no switch port IP address. Beautiful. Let's go to this computer here. We're gonna go to show run. We have that exact same thing: interface port channel, no switch port IP address. Obviously IP address isn't exactly the same. That would be a recipe for a mistake. Let's go to show ether channel, summary. Okay, and you guys can see we have this here. And when we go ahead and we do this, show ether channel summary. Okay, you guys can see we have that as well. Okay, the only thing I'm waiting here for is technically we should have gone ahead and we should have received. Let me go to, let's see what's going on. Let's go to show interface fast Ethernet 0/1. We should have gone and gotten our three triangles, so to speak. But let me do this. Switch 1. This is switch 1. Okay, so we have switch 1 here. We're gonna ping 92.168.0.1, and we have a success. Now we go to here. If we ping 192.168.0.2, should be the same, should be successful. Let's go to our show spanning tree. Show spanning tree. Looks like no spanning tree instance exists. Believe it or not, that's a good sign. Let's go here, and I'm gonna tell you why. Show spanning tree. Let's try that again. Show spanning tree. Okay, so this idea that spanning tree does not exist is exactly the reason why they would use an ether channel on layer 3 with the IP address. A lot of software defined networking, SDN, is actually moving towards what would be getting rid of layer 2. They're going ahead and using a lot more layer 3, and that's what they're trying to go ahead and focus on. So there's no spanning tree instance, no spanning tree instance exists. That's exactly what we want. With regards to why this link is still orange, I that was interesting. I don't know if it was like a ciscopacket tracer glitch, or nonetheless. Let's go ahead. We connected it back. Let's go to show ether channel summary. No, that should be good. We have it running. We can ping. Uh, so that's exactly what we want. And it looks like after I went ahead and connected it back, it looks like it's okay now. But nonetheless, that is the command to go ahead and establish the connection via Ether channel. Let me go ahead, and we could save that for another video. But nonetheless, guys, now you guys have 4 different ways to create an Ether channel summary and this show spanning tree. Once again, that's the whole purpose. Okay, that's the whole purpose. If I were to go ahead and just to prove a point, if I were to go ahead, I connect this to fast Ethernet 20, fast Ethernet 20. Okay, so once again, we already realized that the spanning tree, okay, that this was the priority. Okay, this was the root bridge and this was the non-root bridge. So switch 1 was the root bridge, and we can prove that again. Let's go to show spanning tree. Let's go ahead and look. Did you see how when I connected this link? Did you see how when I connected this link, when I first, or before I connected the link, I was asking show spanning tree. Okay, I said show spanning tree, and it said, hey, spanning tree doesn't exist. As soon as I connected this link here, as soon as I connected this link here on an interface that is not considered an ether channel, but it's just considered a default interface, so to speak, um, you guys can see that that spanning tree came back on. So that's actually exactly what I mentioned before, guys, when it said, hey, and I can prove it to you again. I'm going to get rid of this link. Okay, we got rid of that link. I'm going to go back to my switch. I'm going to go to show spanning tree. And look, spanning tree, no spanning tree instance exists. Why? Because these 3 switches, or rather, excuse me, these 3 interfaces are now on the layer 3. Okay. As far as these switches are concerned, there's nothing connected on the layer 2. Physically, it might be, but logically, these are layer 3. This ether channel is now communicating via IP addresses. Okay, and you guys saw exactly that as a result when we created our Ether channel via layer 3. It's saying, hey, there's no spanning tree. As soon as we connected a link, you guys can go ahead. We ran the same command, show spanning tree, and it's letting you know, hey, this interface here. We removed that interface, and as you guys can see, no spanning tree instance exists. So let's keep that there, guys. If you have any questions or comments, concerns, feel free to ask. Overall, that was pretty good. Like I said, I'm trying to work on shortening up these videos, but once you get to one topic, it kind of becomes a cluster bubble where it's just, hey, this topic, you might have questions about this, and that's the great thing and the cool thing about networking. It's just one idea leads to two ideas. Those two ideas just go ahead and multiply exponentially. So nonetheless, we'll leave it there. Other than that, I wish you guys the best of luck and a wonderful day.